The domain is, sorry, what? All real numbers, that's correct. It is all real numbers. So what did you go after next? Yeah, let's go with intercepts. Let's knock off the easy stuff. We rearranged the acronym before, which was great, but it also means that sometimes you have the harder stuff first. Let's do the intercepts first. When x is 0, what's y? When x is 0, what's y? It's 1, right? And then there's this cross, so 0, 1. Now, is this possible right here? What happens when y is 0? The output is 0. What can you plug in to make that happen? 1 and negative 1. So we have intercepts. That's great. Nice. So you want to go after what next? Critical numbers. Critical numbers. Yay, critical numbers. So in order to go after critical numbers, we need to take the... So let's rearrange this first. This is going to be x squared minus 1 to the what power? To the 2/3. So what's y prime equal to? 2/3. To the negative 1/3 times 2x. And how does that simplify?
4x over 3x squared minus 1.
Yeah, 4/3 x times x squared minus 1 to the negative 1/3. If we're going to have to analyze this, we might as well rewrite it without a negative exponent. So what do you end up with? 4x over 3 times the cube root of x squared minus 1. And it's not 3 cubed, it's... Why did I write 3 cubed?
It's the cube root.
It's... Oh, that's... Wow, I have a short memory. The cube root like that. Okay, so we're interested in where does that equal 0 for critical values. Where does that equal 0 or is undefined? Where is it 0 or undefined? So x equals 0 or what? Plus or minus 1. It's undefined there. Okay, so this is where the concavity can change, right? So we have 0, we have x, and we have y prime. We also have it at negative 1 and positive 1. So what is the derivative at 0? Positive, negative, or 0? We just figured that out. It's 0, yeah. And what is it at negative and positive 1? Nope. It's undefined. It's not 0. Undefined. So now what do we need to do? How many regions do we need to test? 4 of them. 4 of them. Let's do that. So let's test those regions. To the left of negative 1, if we plug in negative something big, what is it? What happens if we plug in negative 2 into this? What does the top become? It becomes positive in the denominator. Why does it become positive in the denominator? Well, you're squaring it and then cube rooting it. So overall it's going to be?
Negative.
It's going to be negative, right? Do you agree? If you plug in negative 2 into that, you're going to get negative 8 on top, and then on the bottom you're going to get a positive. Negative over positive is a negative. So what happens if you plug in negative a half right in here? What happens? It becomes positive, right? It becomes positive. What happens if you plug in a half? What happens if you plug in a half? You sure? You're positive? Don't give up so easily. Come on. Between 0 and 1, if you plug in a half,
It's going to be negative.
you plug in that's going to be 1/4. It's going to be a negative. Cube root of a negative is a negative. What's it going to be? It's going to be negative. And then what's going to happen after 1? Plug in a... It's going to be positive. So where is this thing increasing? Where is it increasing? Come on. Nope. Negative infinity to what?
No.
Oh, why not? Wait.
Because it's
Oh, it's decreasing. I'm sorry. I meant to say decreasing. Very sorry. Decreasing. Negative infinity to what? Union 0 to 1. And where is it increasing? Negative 1 to what? Union 1 to infinity. Exactly. So that's where it's increasing. What can you tell me about what's going on here? What kind of point is that? What's going on at 0? It's going up and then down. So what's happening at 0? We don't know that yet because we Not necessarily, but we strongly suspect that. First derivative. It's going up and then going down. So what's happening at 0?
It's crossing. It flattens out, but it's crossing.
Correct. If you go up and then down, where are you? Up here. A maximum. Thank you very much. Excellent. So then what's happening at these 2 points right here? Negative 1 and 1. Minimums. They're minimums. Because they're going down and then up. Ah, so we have the max. We already know something about the max. What point is that max? Max at what point? 0, 1. We already figured out it's 0, 1. Didn't we figure it out up here? Right? Intercept 0, 1. So there's a max there. And then we know that there are mins where? We already found the other 2 mins, which is kind of cool. The mins are 1, 0, and negative 1. Negative 1, 0, and 1, 0. Great. Okay, so we have the mins and maxes. That's fantastic. Okay, so now we have the domain, the intercepts, and the mins and maxes. What's next? What do we find out? What? Let's examine concavity. Exactly. Concavity. Concavity. Nice. So if we examine concavity, which derivative do we need to look at? Yeah, we had a nice simplified first derivative, which was what? 4x over what? 3 times the cube root of what? X squared minus 1. Like that, right? So what rule do we need to use? Yeah, we could use the quotient rule. We could also flatten this out and use the product rule. Do you want to use the quotient rule right now, or do you want to use the product rule overall? Product rule overall? Okay, that's a fine choice. So it's going to be 4/3 times x squared minus 1 to the... So now we're going to take this. This was y prime, sorry. So we need to do with y double prime. The 4/3 stays out front. What's our first function? Which one is our first function?
X.
What's our second function?
X squared minus 1.
Exactly. So the derivative of the first times the second plus the first times the derivative of the second to the what power? Negative 4/3. Thank you. Times what? Times 2x. Exactly, because of the chain rule. What do we need to do to this before we can really analyze it? We should clean it up. Exactly. We should simplify. So we get y double prime is going to be equal to, well, that 4/3 is kind of irrelevant to our math. So what do we have here? 1 over the cube root of x squared minus 1 minus, right? Minus what? Minus 2x squared over what? 3, right? I haven't done the other one yet. Actually, you know what? Let's keep this. I'm gonna keep this out here. Actually, I'm gonna keep it as. I'm not gonna flatten it. I'm not gonna expand it like that. Minus 2x. Do you see where I get the 2x squared? Minus 2x squared over 3 times what? Squared minus 1 to the negative 4/3. What can I factor out of both of those? Let's factor out x squared minus 1 to the negative 1/3. Why are we factoring things out? Why is it nice to factor things out? What are we searching for? When it equals 0. We want to make this a product of things. So we end up with 2x squared over 3 times x squared minus 1 to what power? Negative 1, yeah, negative 3 over 3, which is this negative 1. Is that a nice cleaner form? I think so. So that y double prime is equal to 4 over the cube root of, well, 3 times the cube root of what? 1 times 1 minus 2x squared over what? 3 times x squared minus 1. Excellent. Let's pause this for a second here and see what we think. Record? Okay, great. Nice. So 1 is equal to what? 2x squared over 3x squared minus 3. So 3x squared minus 3 is equal to 2x squared. So x squared is equal to 3. So x is equal to cube root of 3? Plus or minus root 3. Is that relatively a nice answer? That's relatively a nice answer. So what are we checking now? We're checking negative 1, positive 1, root 3, and negative root 3. And these are the x values, and we're interested in finding out about the y double prime values, correct? And what happens at negative root 3? It's 0 here and 0 here. But what happens at negative 1 and positive 1? It's undefined. So again, let's copy down that second derivative. Here it is right here. So here's our second derivative. We need to know about the sign of this second derivative. We need to know about the sign of this second derivative right here. What number? What's the easy region to test? Easier one. Yeah, negative 1. That region is easy to test. That's correct. So let's plug in what? 0, right. So if we plug in 0 into this thing, what do we end up with? Positive or negative? What do you think? If you plug in 0, what does this become? 0. If you plug in 0, what does this become? Negative, right? So what's it going to be? So it's negative from there to there. That's definitely true. Do you agree with that? You agree with that? Okay. One other thing we need to go back. I just had an epiphany we need to check. Let's go back to the first question here. Is the domain truly all real numbers? Are we sure of that? I think so, because you can plug in any number into there and it squares it, and you can take the cube root of any number. Okay, just making sure. Just want to make sure we're not operating outside our domain. So now, what are the other regions that would be easiest? There's 5 regions here, right? 1, 2, 3, 4, 5. What would be some easy regions to test? Let's test, how about out here? What numbers? Yeah, plug in 2, right? Plug in 2 into this, what do you get? This is going to be a 1 minus, what do you get? Yeah, you have to be careful. You have to know, is it going to be less than or equal to 1, right? We had 0, 1 and 1, 0, and what else? Negative 1, 0. Nice. Is it symmetric? This is a great graph. I love this one. It's symmetry? Yes, it's even. Where's it increasing? Do you remember? Yeah, I know. There's a lot to remember here. It's increasing from, I remember it was negative 1 to 0, union 1 to infinity. And where was it decreasing? Yeah, to negative 1, union what? 0 to 1. And then we know that there's a max where? We know there's a max where? 0, 1. And where are the mins? Negative 1, 0, and 1, 0, right? And we have inflection points, right? What are our inflection points? Inflection points. We know one of them happens at negative root 3, and the other one happens at positive root 3. That's what I was getting at. We need to know the y values, right? Yeah. How do we find the y values? Don't use the calculator. How do you find the y values? Original equation. That's a really common mistake. You find some critical value, and then you don't plug it into the right one. So what was it? Cube root of x squared minus 1 squared. It's actually not that bad. Not that bad. So you have the cube root of x squared minus 1 squared. So what's f of, it's going to be the same thing, right, because it's an even function. What's f of the square root of 3 going to be equal to? It's going to be the cube root of 3 minus 1 squared. So it's going to be the cube root of 4. So this is the cube root of 4, and is there any other information we can figure out here? We haven't done one thing. We haven't checked for what? We did concavity. We just did a ton. Oh, we haven't written it down. I'm sorry. We haven't written it down. You're absolutely right. I'm sorry. So for concavity, where is it concave up? It's where the second derivative is positive. Where was the second derivative positive? Negative infinity to, no. Negative root 3. Union root 3 onward, right? Root 3 onward. And then where's it concave down? Everywhere else, which is negative root 3 to root 3, right there.
It doesn't matter if there's a...
Hold on a sec.